हेलो फ्रेंड्स। सो आज हम बेसिक मैथ्स में कंटिन्यू करेंगे आगे एंड हम पढ़ेंगे कि एल्जेब्रिक आइडेंटिटीज़ क्या होती है। सो मैं आपको सबसे पहले नोट डाउन कर देता हूँ कुछ जो बेसिक आइडेंटिटीज़ होती है, जैसे कि द फर्स्ट वन इज़ a+b होल स्क्वायर। सो दिस इज़ इक्वल टू a+b मल्टीप्लाइड बाय a+b इन द ब्रैकेट। एंड अगर हम इसको ओपन करके सॉल्व करते हैं तो इट्स सिंपली a स्क्वायर प्लस ab plus ab and plus b square, which is a square plus 2ab plus b square. And similarly the second one is a minus b whole square, right? So ये क्या होती है? This is equal to a square minus 2ab plus b square, right? This is just the simple one. Then third one is a plus b plus c, like यहाँ पे एक और थर्ड टर्म में अगर ऐड कर दूँ c, then it will be equal to simply a plus b plus c multiplied by a plus b plus c, right? Or you can just write it down as you can just write down this one, like opening it with this one. So this is a plus b, and if you multiply with this a plus b, then it becomes a square plus b square plus 2ab, right? This a plus b multiplied by this a plus b. Similarly, if I multiply this a plus b with this c, then it will become c multiplied by a plus b, right? Similarly, if I multiply this c with the a plus b plus c, then it will become c multiplied by a plus b plus c. Now if you open it, you will find a square plus b square plus 2ab plus ac plus bc and plus ac plus bc plus c square. Now if you add all these similar terms, so it becomes a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? So this is equal to this one. I hope कि आपको समझ में आ गया होगा. You can just pause the video and write it down, and उसके बाद हम next वाली identities भी लिख लेते हैं. So this is just like the basic ones. Then next one जो हम study कर सकते हैं, fourth one, वो है cubic identity a plus b whole cube. A plus b whole cube identity. So if you notice properly, we can write it as a plus b whole square and multiplied by a plus b, right? This dot represents multiplication. So this is simply a square plus 2ab plus b squared and multiplied by a plus b. And now if you open the bracket, you get a cube plus 2a square b plus 2ab square, right? We multiply a with this, all the terms, and plus we get a cube 2a square b plus sorry, I just made a mistake. I'm multiplying a with this term, so I just forgot this one. Here we will just write down ab square, and now we multiply b with this one, so it will be a square b plus 2ab square and plus b cube, right? So now if we solve this one, like this term and this term and this one and this one, they both are similar. Similarly, they both are same. So it just becomes a cube plus 3a square b plus 3ab square plus b cube. And now if you see, 3ab and 3ab can be common from these both. So it will be a cube plus 3ab, in the bracket it will be a plus b and plus b cube. So this is the identity, a cube plus 3ab, in the bracket a plus b cube. And similarly, for a minus b whole cube, the identity for a minus b whole cube will be, this is just equal to this one, so you can just note it down, right? This is a cube minus b cube minus 3ab a minus b, right? This is simply this identity only, same like this. We just solve this one. Or if you want to see the proof of this one, then here we have, instead of b we put the minus b, right? So in this identity, instead of b, if you put minus b, you will get minus 3ab and minus b cube. So this is just a simple proof, but if you want to fully open it and solve it like that, you can try it again, right? Otherwise you just put minus b instead of plus b in the final solution. Here you'll get the same one, right? So this is this one, and then we go with the cubic identity of 3 terms, right? So that will be a plus b plus c whole cube. That's, I think, probably a new one for many of you, and we can write that as a plus b plus c whole cube. And if you notice properly, what can I write a plus b? I can write, let's write a plus b equals y. I'm saying that this is y, okay? So I'm just proving it, and proof. Okay, so I'm saying this is y plus c whole cube, right? So this is again same like a plus b whole cube. This is y cube plus 3yc instead, and inside it becomes y plus c, right? We just saw it in the last identity. I'm saying a plus b is y, and now what I'm doing is I'm putting a plus b instead of y here. Now I'm putting again a plus b. So if I put a plus b, then it will be a plus b whole cube plus 3 times a plus b multiplied by c, and in the bracket again a plus b plus c. All right, and now if you open it, you get a cube plus b cube plus 3ab a plus b, and similarly plus 3 times, you get here a plus b and a plus b, and you get c multiplied by a plus b plus c, right? Now if you look at properly, we can just take it common, 3a plus b and 3a plus b. So a cube plus b cube plus 3 times a plus b, and in the bracket we get ab, and here we get c multiplied by a plus b plus c. So if I multiply them and I put them here, I will be getting ac plus bc plus c square, right? So I'm just multiplying it with this one. I got this one, and now again if I'm solving it, I get a cube plus b cube plus, if I take common from here, what I will be getting is, and sorry, this is c cube here plus c cube, okay? This is plus c cube here, plus, like this is the bracket, c cube plus c cube, everywhere plus c cube. So I'm just writing it plus c cube here because I just forgot from here, right? And then this will be plus times 3 times a plus b, and if I take a common here, I will get b plus c. Similarly, if I take c common, I'll be getting b plus c again, and I'm closing the bracket. So now if you look properly, carefully, we can take b plus c as common. So finally we get a cube plus b cube plus c cube plus 3 times a plus b, and this is b plus c multiplied by a plus c. So this is what we get, a cube plus b cube plus c cube plus 3 times a plus b plus c, and a plus c. So you can just write it down as a cube plus b cube plus c cube plus 3 times a plus b plus c, and c plus a, right? So this is the proof of this identity, and it's always true. Whatever the values of a, b and c are, it will be always true. It will be always equal to this one. I hope you will have understood this one, and now we can erase this. So just erasing this one, and so next one is like conditional identity. You can say it as a conditional identity. So this one says like a cube plus b cube plus c cube is equal to 3abc. This is true only when a plus b plus c equals 0, or a plus b, a equals b equals c. If a, b and c, all of them are equal, then it is true. Or otherwise, if a plus b plus c, the sum of all the three numbers here is 0, all the three terms, then only it's true. Otherwise it's not true, right? So it's a conditional identity. So this is a conditional identity. And similarly, the another identity which we can write is a to the power 4 plus a square plus 1. This is equal to a square plus a plus 1, a square minus a plus 1, right? This is just equal to this one, and you can prove this one. So the proof is a to the power 4 plus a square. I'm just making 2a square plus 1 and minus a square. Okay, so I'm just adding a square and subtracting a square. And now if you look at it, this is just a to the power 4 plus 2a square plus 1, which is a square plus 1 whole square and minus a square, which is again equal to this whole term, p square minus q square. So which is a square plus 1 minus a square plus 1 plus a, right? So this is another identity which you can remember. And these are pretty much the identities. I hope you can pause the video and just write it down. And now we can just solve the question. And another important thing to note is that all the identities are always true. It doesn't matter whether these numbers are real or they are imaginary. So they are always true, whether the numbers are rational, irrational or imaginary. So we can just solve a question. It is given that, like, this is a question, and we are given a plus b plus c is equal to 0, and we need to find the value of we have to find value of a to the power 4 plus b to the power 4 plus c to the power 4 divided by whole square of ab plus whole square of bc plus whole square of ca, right? We have to find this one. So we are given this one. So that means a plus b plus c is 0. What does that mean? If I square it, if I just take the square of this one, then I will get a square plus b square plus c square minus plus 2 times a plus 2 times ab plus 2 times bc plus 2 times ac, right? And equal to 0. All right. And now if I bring these terms on the other side, then I get a square plus b square plus c square is equal to minus 2 times ab plus bc plus ac, right? And now if you look at it, this one, if I again take whole square of this term, so this will be a to the power 4 plus b to the power 4 plus c to the power 4, right? And plus 2 times a square b square plus b square c square plus c square a square, right? This is just like x y z. So x square plus y square plus z square plus 2xy yz and zx is equal to, if I take the whole square of this side, then it will be this 2 will become 4, and in the bracket this will be a square b square plus b square c square plus a square c square, right? And now it will be multiplying these both the terms, so that will be 2 times ab square c plus 2 times a square bc plus 2 times abc square, right? So, and now if you look at it, this is 4a square b square, and this is 4b square c square and 4 square c square, so they will get subtracted. So if I solve it on the top, these terms will be a to the power 4 plus b to the power 4 plus c to the power 4 will be equal to this one, 2 times a square b square plus b square c square plus c square a square. And if you see this one, ABC and ABC is common, right? This is equal to 2 times of this one plus this is 4 in the multiplication, and I'm just taking a b c common, and this 2 also, so 2 multiplied by 4 in the common, and inside you get a plus b plus c, which is equal to 0. So then this term will be, whole term will be 0, right? So we just get a to the power 4 plus b to the power 4 plus c to the power 4 is equal to 2a square b square plus b square c square plus e square a square. This is everything in the bracket. Okay, so in the finally what we get is, we substitute this term here and we get 2. So I hope you would have understood this one. We just have to substitute this value over here and you just get 2. Alright, so this is all for today. Thank you, and I'll see you in the next video.